Imagine standing in a bustling city when suddenly the ground starts to tremble beneath your feet. Buildings sway, people look around in confusion, and cracks begin to form in the roads. What could cause such a dramatic event? Earthquakes can strike without warning, powerful enough to reshape entire cities in just seconds. But these events aren't random. Deep below the surface of the Earth, massive forces are constantly at work, setting the stage for these sudden shakes. Understanding what triggers an earthquake starts with looking beneath our feet, where invisible movements are always happening. Beneath the surface, Earth's outer layer is broken into huge pieces called tectonic plates. These plates float on a sea of hot molten rock known as magma. They are constantly moving, though usually so slowly that we don't notice. This movement is part of a giant hidden puzzle that shapes our planet. Most of the time these shifts are invisible to us, but they are always happening. The slow drift of tectonic plates is a fundamental part of Earth's dynamic nature, setting the stage for the powerful forces that can lead to earthquakes. Sometimes tectonic plates don't just drift, they collide, pull apart, or slide past each other. Their edges are rough and uneven, so when they meet, they can get stuck. As the plates continue to move, pressure builds up along these stuck edges. This pressure can accumulate for years, decades, or even centuries, creating a ticking time bomb beneath the surface. The slow but relentless movement of plates is what makes earthquakes possible, as the energy stored in these stuck edges is waiting for a chance to be released. When the built-up pressure becomes too much, the rocks underground suddenly break and slip. This rapid movement releases a huge amount of energy, sending shockwaves outwards from the break. These shockwaves, called seismic waves, travel through the earth and reach the surface, causing the ground to shake. This is the moment an earthquake happens. The sudden release of energy is what makes earthquakes so powerful and unpredictable, turning years of silent buildup into seconds of dramatic shaking. Every earthquake starts at a specific point underground called the focus. The spot directly above this on the Earth's surface is known as the epicenter. This is usually where the shaking is strongest and most destructive. Understanding the difference between the focus and the epicenter helps scientists pinpoint where an earthquake began and how its energy spreads. The epicenter is often the place where people feel the most intense effects and where damage is most severe. Understand and track earthquakes, scientists use special instruments called seismographs. These devices record the seismic waves produced by earthquakes, allowing experts to measure their strength. The magnitude of an earthquake is determined using scales like the Richter scale. Even a small increase in magnitude can mean a much stronger and more dangerous quake. Measuring earthquakes helps us understand their impact and prepare for future events, making seismographs a crucial tool in earthquake science. Not all places on Earth experience earthquakes equally. Some regions are much more prone to shaking because they sit on the boundaries of tectonic plates. These areas, known as earthquake zones, are where plates interact most actively. The movement and collision of plates in these zones make earthquakes more frequent and intense. Understanding why some areas shake more than others helps us identify regions at higher risk and prepare for future events. One of the most famous earthquake zones is the Ring of Fire, a region encircling the Pacific Ocean. This area is notorious for frequent earthquakes and volcanic eruptions because it's where several tectonic plates meet. Countries like Japan, Indonesia, and the west coast of the Americas are part of this ring. The Ring of Fire's intense geological activity makes it a hotspot for natural disasters, shaping the lives and landscapes of millions. Fault lines are cracks in the Earth's crust where tectonic plates meet and move. These lines are the sites of many earthquakes as the plates slip and release energy. Famous fault lines include the San Andreas Fault in California and the Himalayan Fault in Asia. Living near a fault line means a higher risk of experiencing earthquakes, making it important to understand their locations and behavior. When an earthquake occurs, energy travels outward in the form of seismic waves. These waves move through the earth, shaking the ground as they go. There are different types of seismic waves, including primary waves, P waves, and secondary waves, S waves, each moving at different speeds and causing different effects. The way seismic waves travel helps scientists understand the size and impact of an earthquake. After the main earthquake, smaller tremors called aftershocks often follow. These can occur minutes, hours, or even days later, sometimes causing additional damage. Aftershocks happen as the Earth adjusts to the new positions of the tectonic plates. While usually less powerful than the main quake, aftershocks can still be dangerous and unpredictable. Magnitude of an earthquake measures how much energy is released. Scientists use scales like the Richter scale to assign a number to each quake. A higher magnitude means a stronger earthquake, with more intense shaking and greater potential for damage. Even a small increase in magnitude can make a big difference in the impact felt by people and buildings. While magnitude measures the energy released, intensity describes how strongly the earthquake is felt in different places. Intensity depends on factors like distance from the epicenter, local geology, and building structures. Some areas may feel only a gentle shake, while others experience violent movement. Scientists use intensity scales to record these differences and understand the effects on communities. Seismographs are sensitive instruments that detect and record the vibrations caused by earthquakes. They help scientists track seismic waves and measure the strength of each quake. Seismographs are placed all over the world, forming a network that monitors Earth's activity. This data is crucial for understanding earthquakes and issuing warnings when necessary. Scientists are constantly working to predict earthquakes, but it's a challenging task. While they can identify high-risk areas and monitor signs of movement, predicting the exact time and place of a quake is still impossible. Research continues to improve our understanding, but earthquakes remain one of nature's most unpredictable events. Being prepared for earthquakes can save lives. This includes having emergency kits, knowing safe spots in your home, and practicing drills. Communities in earthquake-prone areas often have strict building codes and public education programs to reduce risk. Preparation is key to minimizing the impact of future earthquakes. Modern buildings in earthquake zones are designed to withstand shaking. Engineers use flexible materials and special techniques to absorb energy and prevent collapse. Retrofitting older structures is also important for safety. These innovations help protect people and property when earthquakes strike. Practicing earthquake drills helps people know what to do when shaking starts. Schools, workplaces, and families often run drills to teach safe actions like drop, cover, and hold on. These routines can make a big difference during a real earthquake, helping everyone stay calm and safe. Some countries have early warning systems that detect seismic waves and alert people seconds before shaking arrives. These warnings give people a brief moment to take cover or stop dangerous activities. Early warning technology is improving, helping communities respond faster and reduce injuries. Earthquakes can cause widespread damage to buildings, roads, and infrastructure. The shaking can lead to collapsed structures, broken pipelines, and disrupted services. Recovery can take months or years depending on the severity. Understanding earthquake damage helps communities plan for rebuilding and support. After a major earthquake, rescue teams work quickly to find survivors and provide aid. Search and rescue operations are crucial in the first hours after a quake. Teams use specialized equipment and trained dogs to locate people trapped under debris. Their efforts save lives and bring hope to affected communities. Recovery after an earthquake involves rebuilding homes, restoring services, and supporting affected families. Governments and aid organizations work together to provide shelter, food, and medical care. The process can be long and challenging, but communities often come together to help each other rebuild. Scientists study earthquakes to learn more about how and why they happen. Research includes monitoring plate movements, analyzing seismic data, and developing new prediction methods. This science helps us understand Earth's dynamic nature and improve safety for people living in earthquake zones. Throughout history, earthquakes have shaped cities and civilizations. Famous events like the 1906 San Francisco earthquake and the 2011 Japan earthquake changed landscapes and lives. Studying past earthquakes helps us learn from mistakes and prepare for future challenges. Many myths surround earthquakes, such as the idea that animals can predict them or that certain weather causes quakes. Scientists have debunked most of these myths, showing that earthquakes are caused by plate movements, not by animals or weather. Understanding the facts helps us stay safe and informed. Some earthquakes, especially those under the ocean, can trigger tsunamis. These giant waves travel across the sea, causing destruction when they reach land. Tsunamis are dangerous and can follow minutes after an earthquake, making coastal preparedness essential. Earthquakes and volcanoes are closely linked, especially in areas like the Ring of Fire. Movement of tectonic plates can trigger volcanic eruptions, and eruptions can cause earthquakes. Understanding this connection helps scientists predict and prepare for both types of disasters. During strong earthquakes, soil can behave like a liquid, a process called liquefaction. This can cause buildings to sink or tilt, making damage worse. Liquefaction happens when shaking loosens the soil, especially in areas with loose, wet ground. Earthquakes can trigger landslides, especially in hilly or mountainous areas. The shaking loosens rocks and soil, causing them to slide down slopes. Landslides can block roads, destroy homes, and create new hazards after an earthquake. Fires often break out after earthquakes, caused by broken gas lines, electrical faults, or damaged infrastructure. Firefighters work quickly to control these blazes and prevent further destruction. Fire safety is an important part of earthquake preparedness. Many people in earthquake-prone areas buy insurance to protect their homes and belongings. Earthquake insurance helps cover the cost of repairs and rebuilding after a disaster. It's an important tool for financial recovery and peace of mind. Countries around the world hold earthquake drills to teach people how to stay safe. These drills include practicing evacuation, finding safe spots, and learning emergency procedures. Global cooperation helps share best practices and improve safety everywhere. Modern technology includes smartphone apps that provide earthquake alerts and safety tips. These apps use data from seismographs and warning systems to keep users informed. Having an app can help you respond quickly when an earthquake strikes. Education about earthquakes is vital for safety. Schools teach students about plate movements, earthquake drills, and emergency preparedness. Public awareness campaigns help everyone understand risks and how to stay safe during a quake. Research into earthquakes continues to advance, with scientists using new tools and methods to study plate movements and seismic activity. This research helps improve prediction, preparedness, and response, making communities safer and more resilient. Earthquake maps show where quakes have happened and highlight high-risk areas. These maps help scientists, governments, and the public understand patterns and prepare for future events. Accurate mapping is a key part of earthquake safety. Scientists use computer simulations to model how earthquakes happen and predict their effects. These simulations help test building designs, emergency plans, and response strategies. By simulating earthquakes, experts can better prepare for real events. Sometimes, small signs appear before a major earthquake, like tiny tremors or changes in groundwater. Scientists monitor these signs to try and predict larger quakes. While warning signs aren't always reliable, they are an important part of earthquake research. Emergency response teams are trained to act quickly after earthquakes. They provide medical care, rescue services, and support for affected families. Coordination between agencies is crucial for effective response and recovery. Communities often come together after earthquakes to help each other. Volunteers provide food, shelter, and emotional support. Community spirit is vital for recovery, showing the strength and resilience of people facing disaster. Knowing safety tips can help you survive an earthquake. Stay away from windows, take cover under sturdy furniture, and hold on until the shaking stops. After the quake, check for injuries and hazards before moving around. These simple actions can save lives. Communication is vital during and after an earthquake. Emergency alerts, radios, and phones help people stay informed and connected. Reliable communication ensures that help reaches those who need it most. Funding for earthquake recovery comes from governments, insurance, and donations. Financial support helps rebuild homes, restore services, and assist families. Recovery funding is essential for helping communities bounce back after disaster. Resilience means being able to recover quickly from earthquakes. Strong communities, safe buildings, and good planning all contribute to resilience. Learning from past events helps us build a safer future and withstand the challenges of earthquakes. Earthquakes are powerful forces that shape our planet. From the movement of tectonic plates to the sudden release of energy, understanding earthquakes helps us stay safe and prepared. Science, technology, and community support all play a role in reducing risk and building resilience. By learning about earthquakes, we can protect ourselves and our world from their unpredictable power.